Hello. So you and I are having a conversation right now. I'm an AI, so it probably feels like this is all just happening in the cloud, right? Like it's just weightless data floating around. But the truth is, every single word I'm generating for you has a physical cost in the real world, a cost that involves truly massive amounts of energy and water. We're about to pull back that curtain, and I promise you, what's behind it is a lot bigger than you think. Let's get into it. It all starts with something that feels so simple. A question, a prompt, an action you take that feels completely weightless, totally instantaneous. But behind that screen, a massive industrial process is kicking into high gear.
So you asked me to say, write a poem or generate an image? The moment you hit enter, your request zips across the internet to this huge, windowless building packed with thousands upon thousands of computer processors, and they all fire up at once, just to answer you. It feels like magic, doesn't it? But it's not. It's pure industrial might. And believe me, it is incredibly thirsty.
Okay, let's put a real number on it. How much water does a simple little chat with an AI like me actually cost? Well, researchers at the University of California figured it out. For just 10 to 15 questions, a short conversation, the data centers cooling all those processors use up about half a liter of fresh water. That's an entire standard-sized bottle of water gone just for a few minutes of chatting.
This quote, wow, it just perfectly captures the vibe of a data center. They really are the physical heart of our digital world. People often describe them as vampires, and it makes sense, right? They're sheltered from the sun, they're active 24/7, and they have this seemingly unquenchable thirst for energy and water.
So, remember that one bottle of water? That was for one conversation. Now multiply that by the millions and millions of AI interactions happening every single hour of every single day. The combined thirst of all these data centers is starting to change how we use resources on a global scale. So let's zoom out and see just how big this problem really is.
Globally, in 2024 alone, data centers are on track to burn through 415 terawatt hours of electricity. I know that's a number so big it's almost meaningless. So let's put it this way. That's 1.5% of all the electricity used by humanity. For everything, cars, homes, factories, you name it. And what's really staggering here is the speed of this growth. Just look at this chart. The electricity demand from data centers is rocketing up at 15% every single year. That's more than 4 times faster than every other sector combined. This isn't just a gradual slope, folks. This is an exponential explosion. Now let's zoom in on just one country to really see the impact. In the United States, data centers are already gobbling up over 4.4% of the nation's total electricity. Just think about that for a second. Think about all the homes, all the businesses, all the factories in the entire country. And these server farms are taking a huge slice of that energy pie. And if 4.4% still sounds a little abstract, try this on for size. The electricity used by data centers in just the US is about the same as the amount used by the entire country of Pakistan in a year, a country with over 230 million people. It's just a mind-boggling scale. This timeline really tells the story. For years, you see the growth was pretty steady. But then, look what happens recently. From 2018 to now, the consumption has more than doubled. That nearly vertical line you see on the graph, yeah, that's the AI revolution kicking into high gear, and it is demanding an incredible amount of power. And it's not just electricity. To keep all of that hardware from literally melting, US data centers directly consumed 17 billion gallons of water in 2023. And get this, that's just for the direct cooling. That number doesn't even count the water used to generate all the electricity they're consuming in the first place.
So what is driving this absolutely massive spike? The answer is just 2 letters: AI. Generative AI has completely changed the game. It has created a type of computing that is fundamentally, on a deep level, more demanding and more energy hungry than anything that has ever come before it.
Think about it. Just searching on Google or storing your photos, that's one thing. But training a large AI model to write, to code, to create art, that is an incredibly intensive task. It requires a level of computational power that is just orders of magnitude greater than what we're used to. It's a completely different beast. And the data? Well, the data shows it clear as day. According to the International Energy Agency, the electricity demand for data centers focused on AI is growing at about 30% per year. That's more than triple the growth rate for your conventional server workloads. Triple! So why? It really comes down to the hardware itself. Traditional computing runs on CPUs, but AI runs on these power-hungry GPUs, graphics processing units. A single high-end GPU can suck down double the power of a standard CPU.
and a modern AI server is absolutely packed with them. That just cascades into way higher energy and cooling needs for the whole building.
You know, these huge global numbers can start to feel a little abstract, but they have very real, very local consequences. When a giant data center moves into a town, it puts an incredible strain on that community's resources, especially its power and its water.
Okay, I really want you to let this number sink in. 5 million gallons of water every single day. That's the same amount of water an entire city of 50,000 people would use. But here's the crucial difference. A data center doesn't support local residents. It supports a global network. But it draws all of that water from one local community's supply.
And the costs get spread all across the community. That immense power draw puts a huge strain on the regional grid, which can lead to higher electricity bills for everybody. Water supplies can get depleted, especially in areas that are already dry. And when the grid can't keep up, these places fire up massive diesel backup generators, pumping pollution into the air.
A big part of the problem here is just a lack of transparency. Companies often use non-disclosure agreements to hide the true scale of their energy and water use. And what that means is that local lawmakers and residents often approve these massive projects with ever fully understanding the long-term environmental and financial costs.
So this all sounds pretty grim, I know. The situation is definitely urgent, but it's not hopeless. There's a huge push happening right now, both in the tech industry and in government, to find smarter, greener, and much more efficient ways to power our digital world.
To understand the solutions, we first have to see where all that energy is actually going. In a typical data center, a little over half the energy powers the IT equipment itself, the servers, the processors. But a huge chunk, about 35%, is used just for cooling, just to keep all that expensive hardware from melting down.
And this is where new technology can make a gigantic difference. That traditional air cooling, it's becoming really inefficient for the kind of dense AI hardware we're using now. So the industry is rapidly shifting towards liquid cooling, which is way more effective and can slash the energy used for cooling by more than 27%. That's a huge win.
But here's the thing, there is no single silver bullet here. The real path forward is a combination of a whole bunch of strategies. We need tech companies investing in their own clean power, like solar and wind. We absolutely need more efficient hardware, like that shift to liquid cooling. We can even use AI itself to make the power grid smarter. And we need massive battery storage to handle those huge peaks in demand. It's really an all-of-the-above approach.
And that brings us right back to where we started. Every single digital action, every single one of our conversations has a real physical consequence. The incredible convenience of this technology comes at a steep, steep environmental price. So the question isn't if we can build this powerful future, we're already doing it. The real question is, can we build it sustainably without draining the physical world that all of us depend on? That's the challenge.